Welcome to the discussion and thank you for always joining us. This is K.c.s.e 2006 paper 2 question number 23, linear programming, and the question we have reads, Manjoki Flying Company operates a flying service. It has two types of aeroplanes. A smaller one uses 180 liters of fuel per hour, while the bigger one uses 300 liters per hour. The fuel available per week is 18,000 liters. The company is allowed 80 flying hours per week. To keep the aeroplane in good condition, the bigger aeroplane must be flown for X hours a week, while the smaller aeroplane must be flown Y hours per week. A. Write down all the inequalities representing the above information. So what we are going to do, we are going to start by letting the bigger aeroplanes to take X hours, and the smaller one to actually take Y hours in a week. So we are going to proceed as follows. Remember, the bigger aeroplane flies for X hours a week, and per hour it is going to use 300 liters of fuel, and therefore the total number of liters will be 300 liters per hour. We multiply by X plus the smaller one uses 180 liters times the number of hours, so that we can get the total number of liters. And this one is going to be less or equal to 18,000 liters. If you divide by 60 all through, we are going to have 5x plus we are going to have 3y, and this one is going to be less or equal to 18,000 divided by 60, we get 300, and this becomes the first inequality. We are also told that the company is allowed 80 flying hours per week. That means the number of hours for the bigger aeroplanes plus those of the smaller aeroplanes must be less or equal to 80. This one again becomes the second inequality. We have also been told that to keep the aeroplane in good condition, the bigger aeroplane must be flown for X hours. That one has already been done. So those are the two inequalities. Then we include the negative functions where X is greater than 0 as the third inequality, and the Y being greater or equal to 0 as the fourth inequality. Once that has been done, we can now move and plot the given inequalities and shade the unwanted regions. But before we do that, we are going to start by drawing the tables. For the first one, we are going to have a table having X and Y. Remember, if we say the value of X is 0, then Y is going to be 100. And if I assume the value of Y is 0, then the value of X will be 60. That one is done. Then for number 2, we have X plus Y is equal to 80. So XY, if we assume the value of X is 0, then y is going to be 80, and if we assume y is 0, then x is going to be 80, and that is the table for the two inequalities. What we are going to do is to represent them graphically. For the first one, when the value of x is 0, y is 100 at this point, and when the value of x is 60, at this point y is 0. That is the 2 points that we are going to join using a ruler. So if we use a ruler to join the 2 points, we are going to have a straight line running through the 2 points. We can as well use, after drawing this line, remember what we need is below the line, and therefore we are going to shade the upper part. This line is 5x plus 3y is equal to 300. Next, we are going again to draw another one. For the second one, when x is 0, y is 80 at this point, and when x is 80, y is 0 at this point. Again, we are going to use a ruler to draw a line between the 2 points. That is what we have. After we have done that, we again shade the upper part, because what we need is the lower one. We can also give it a name where x plus y is equals to 80. And once we have done that again, we are going to use the non-negative functions where y is greater than 0 and also x is greater than 0. So we shade this point and get the required region. So the entire of this part here becomes our required region. Again, we go to C. In part C, we are told the profit on the smaller aeroplane is 4,000 per hour, while that of the bigger aeroplane is 6,000 per hour, and therefore the total profit will be 6,000 times the number of hours, plus the smaller one is 4,000 times the number of hours for us to get the total profit. And in this case, what we are going to do is to get the maximum point that we are going to substitute for us to get the maximum profit. And in this case, we are going to have the 4 corner points. We have this point here. We have a point at this corner here. We can also take this corner. We take this corner and also this corner. But the one that is going to give us the maximum will be at this point, where we are going to have at least the value of y at this point and also x down here. So in this case, we are going to have the value of x and the value of y. The value of x from here will be, so if I pick the exact value at this particular corner here, you can see that the value of y is going to be approximately 50, and the value of x is going to be 30. I'm going to take the maximum point at this so that we can get the maximum profit. That means x represents the bigger aeroplanes, and y represents the smaller aeroplane. In this case, if we are going to have x as 30 and y as 50, then we are going to have the maximum profit being equal to 6,000 times the value of x, which is 30, added to 4,000 times the value of y, which is 50, and the total here will be equivalent to 380,000 shillings. That becomes the solution to this particular question. Thank you for watching and welcome to our discussions. And in case you are watching this channel for the first time, please take a second or two, you click the subscribe button so that anytime we publish a video like this, you will automatically be given a notification. Thank you and welcome.